Okay, good afternoon. So today we're looking at the test topic 3, the revision exercise. Okay, at this point you guys have indicated what the questions I needed to have a look at. Okay, you just follow me here. Just let me know you don't make a mistake with it. Okay, you can take it out here. You don't have the answers. You have it? Yeah. The textbook. It's fine. Okay, so in 1.5, of course the question is solve for x. Okay. This is the revision test topic 3. Let's give the reference here. Revision test topic 3. And this is on page. What page is this on? It's on page 58. Page 58. Okay. Let's go. Thank you. So you sorted?
Yes, I'm going to do this part.
Yeah. No, that's fine.
This is the one, yeah.
Yeah, that's the one you have to concentrate on.
Okay.
Right, here we go. So in 1.5, the question says solve for x. So what I'm going to do is, I'm going to divide both sides by 250. So we're going to isolate the base with the exponent first. Okay. So that cancels. So 1 plus 0,6 is 1.6x equals 1,500. 1,500 divided by 250. That gives us 6. So 1.6 to the exponent x is equal to 6. So we change this to log form, so x is equal to log 6 base 1.6. The base remains the base. Okay, so that becomes log 1.6. 6, that gives us 3,81. 3,81. Okay. The next question, 1.6. As you can see here, we notice that both exponents, both the numerator and the denominator exponent is x, which means to say this can be written as 28 over 7 raised to the x equals 10. Now 28 over 7 is 4, not so. So 4 to the x is equal to 10. There we already got now the base with the exponent and the number on the other side. So therefore x is equal to log 10 base 4. Okay, and that now gives us log 10 base 4. It gives us 1,66. Any issues there? No? Let's carry on. In number 2, we are told if log x base 3, log 5 base 3 is equal to x. Find the value of 3 to the 0 plus 3 to the x plus 3 to the 2x. Alright, so we know that anything to the power 0 is 1. Anything to the power 0 is 1 plus 3 to the x. Now remember that log 5 base 3 is equal to x. So if we look at this here, that is giving an exponential form. So I must convert this first to exponential. So this is going to be 3 to the x equals 5. So you see here there's 3 to the x. So that's going to be plus 5 plus. Now 3 to the 2x can be written as 3 to the x squared. Not so. So that is going to be 3 to the x is 5, so 5 squared is 25 plus 5 is 30. The answer is 31. Okay. Question 6. In question 6 we are given the function f of x equals b to the x, which is exponential graph, and b is greater than 0. Which means to say b is positive. Find the value of b if the point -2 and 9/4 lies on f. 6.1. So we will substitute -2 and 9/4 into f of x. Okay, remember this is x and a y. So we have 9/4 equals b to the -2. Now b to the -2 is the same as 1/b squared, 9/4. Cross multiply. So 9b squared is equal to 4 divided by 9. So b squared is equal to 4/9. Okay? Square root from there, plus minus. But since b is greater than 0 as indicated there, it will be 2/3. So the equation of f of x is going to be 2/3 raised to x. Okay. 6.2. Find the equation of the inverse f to the -1, the inverse of f in that form. What do we do for the inverse function? We interchange x and y. So we say for the inverse, that is y is equal to 2/3 raised to the x. So we'll have x is equal to 2/3 raised to the y. So therefore y is equal to log x base 2/3. And that is your equation of your inverse function. Alright, so it's y is equal to log x base 2/3. 6.3. Give the equation of the line about which the inverse and the function is symmetrical. Remember, the inverse function is the reflection of the function in the line. Y is equal to x. Remember the whole inverse story when we introduced that, we told you that the inverse function is the study of the graph in the line y is equal to x. The reflection of the graph in the line y is equal to x.
Afternoon, sir.
Good afternoon. 6.4. Draw the graph of f and its inverse on the same system axis. So we're going to draw. So for your function, for f of x, this is now for f of x, no? Which is equals 2/3 to the x. So the values I choose here is -1, 0 and 1. So that gives you 3/2, 1 and 2/3. So if I draw that graph, okay, this is -1, 0 and 1. That is 1, 2, 3. So there's 2, 1. Okay, so if that is now -1, -2. So -1 is 1.5. Okay, 0 is 1, 1 is 2/3. So the graph is going to come through like this. Okay, and this is the graph of f. Okay. Then what do we do for the inverse function? We interchange x and y, not so. So for the inverse function, let's just draw this in blue. So for the inverse function, the table now is going to look like, there's your x and your y, -1, 0 and 1. This is going to be 3/2, 1 and 2/3. Okay, so x is 1, 2, 3 here. So x is 1.5, which is approximately there, and -1. So it's 3/2 and -1. Then 1 and 0, and 2/3 and 1. 2/3 and 1. Okay, so the graph is going to come through like that. Cut this graph. It's not a very good representation of what's happening here. When you come close there, graph does that. Okay, you guys understand? Alright. And this is the inverse function. And remember, this graph is reflected in the line. Y is equal to x. Okay? That's your inverse function. Another graph. Okay, draw the graph of f and the inverse of the same system. Show the intercepts with the axis and the coordinates of two other points on each graph. Now those are the points in the other. H of x must look up. Okay. Let's carry on. So in 6.5.6 we are told, let's pull this up here. 6.5 we are told write down the equation of H, the reflection of F in the x-axis. So if something is reflected in the x-axis, what happens? Y becomes negative. So reflection this is the reflection in the x-axis. Reflection in the x-axis, y becomes negative. Not so. So it's a reflection of f of x. What's the equation of f of x? F of x equal to 2/3 raised to x. Not so. So reflection in the x-axis, y becomes negative. So negative y is equal to 2/3 raised to the x. So therefore, y equals negative 2/3 to the x. And this is the equation of h of x. Okay. 6.6, draw the graph of h on the same system of axis as that inverse function there. The function and the inverse function. The equation of f is reflected in the x-axis. F. So this is your f graph, not so. So 1 and 0 becomes 0 and 1 becomes 0 and minus 1. Not so. This is 1 and 2/3 become 1 and minus 2/3. Not so. This point here, which is negative 1 and 1.5 becomes negative 1 and negative 1.5. You see that, people? So as this asymptote remains its asymptote, but there's that graph. And this is your H graph, H of x. Can you see that, people? If I fold this graph close in this line here, then this F graph will fall exactly onto this H graph here. Okay? It's important to note that thing. Then we are told to write down the range of h of x. What is a range? All possible y values. Does this graph exist at negative infinity on your y? Yes. Will it stop existing at 0? So in other words, y must be less than 0. Y is to be less than 0 then. 6.6. Y is less than 0. 6.7 to write the... No, that's 6.7. 6.6 was to draw. 6.8. Is h an increasing or decreasing function? So let's look at h. Is h an increasing or decreasing? It is increasing. Why is it increasing? As x increases, the y value increases. You must remember, for increasing and decreasing, we're always reading it from the left to the right. Can you see that, people? So to answer that question, it is an increasing function. As x increases, the value of y increases. Can you see that? As we always go in this direction. As x increases, the value of y increases. Not so. What can we say about f of x, increasing or decreasing? Decreasing. Why? As x increases, y decreases. What can you say about the inverse function of f? It is a decreasing function. Why? Because as x increases, the value of y decreases. Right? You guys understand? Right? Let's carry on. Number 8. Number 8, we are given the graph f of x equals b to the x, where b is greater than 0, b is not equal to 1, g of x equal to. That's a parabola. The second one is a parabola, where it's given in the turning point form, which is a into x minus b all squared plus q out rho. So I think I'm shorting here, yes. I'm shorting some. Okay, so we are told, so we have two graphs, f and g. P and Q are points of intersection. Can you see the two graphs are cutting in? Of the two graphs, Q, which is 1 and 4, is also the turning point. Okay. Then you are told that g of x, Q is also the turning point of g of x, and P is the y-intercept of both graphs, a common y-intercept. Show that P is 0 and 1. So if you're looking at P, okay, I'm going to put it here. Take the calculator away. Write that calculator there quickly. So you can bring that down. So, looking at, we show that the coordinates of P is 0 and 1. But what is P, people? This is a y-intercept, not so. What do you do for y-intercept? We let x equal to 0. So that is your y-intercept of your parabola, and it's your y-intercept of your hyperbola, of your exponential graph, not so. But you can't, if you substitute 0 wherever you see x in your parabola, is not going to make any difference to us. Okay. So what I'm going to do is, I'm going to rather substitute 0 into the g of x graph, no, the f of x graph, which is b to the x. So you say then b, f of the 0 will be b to the 0, which is 1. Therefore, p is 0 and 1. Okay, make sense? 8.2. So this is going to be 1 here. 8.2. Find the values of A, B, P, and Q. Now, if you're looking at this format here, they were nice and gave you the equation is in this form, but normally it's not given in that form. If you are given the turning point, you must remember that formula must be used. If you are given the x-intercepts, then you use the formula y is equal to a into x minus x1, x minus x2. Not so. That's in the x-intercepts are given. But the turning points are given here. So the turning point, sorry. So Q, which is 1 and 4, that is your P value and your Q value. So y is equal to a into x minus P, which is 1 squared plus 4. Okay. Then we still need to work out our A. Not so. Now at this point I'm going to substitute a point that's lying on this graph, which is P. So we'll substitute P in, and P is 0 and 1. Remember, that's an x and a y. So 1 is equal to a into 0 minus 1 squared plus 4. Take it over the equal sign, becomes 1 minus 4 is negative 3. 0 minus 1 is negative 1 squared is 1. So a is equal to minus 3. So what's my equation now? Y is equal to negative 3 into x minus 1 squared plus 4. And this is the equation of g of x. I'm going to write it here because I'm sure I'm going to clear the board now. So it's negative 3 into x minus 1 squared plus 4. Okay. You should G of X graph. So still 8.2, we haven't found the value of B. Not so. We got A, which is negative 3, we got P, which is 1, and Q is 4. Not so. So how do we calculate B? If B of X is coming from F of X equal to B to the X. Do we have a point that's lying on B? Yes, which is Q. So you'll substitute Q, which is 1 and 4. Again, that's an X and a Y. So 4 is equal to B to the 1, so B is 4. So the equation of F of X is simply 4 to the X. Okay. Any confusion? Then it says in 8.3, in question 8.3, I can cut this up. In 8.3 we are told, find the equation of f to the minus x and describe the transformation that took place of f of x. So if you're going to look at f of x, which is 4 to the x, f to the minus x is equal to. So f of minus x will be equal to what? Hey! Guys, make a noise, man. Okay. So what would f of minus x be? It will be 4 to the minus x, or 1 over 4 to the x. You will agree with that? So the question is, describe the transformation. So how does it go from x to negative x? What happens? So reflection is in the y-axis. So reflection in the y-axis. You guys understand? 8.4, describe the transformation of f to h. Now, if you're looking at 8.4 from f to h, but f of x equation is equal to log x. No, f of x is 4 to the x. No, whilst h of x is equal to log x base 4. How do I know h 4? Because we worked out b already. So if I take the inverse function here on f of x, it was interchanging x and y. So y is equal to log x base 4. Is this graph and that graph not the same? Not so? Yes. Describe the transformation of from f to h. What happens? It's the inverse function. So what is the transformation? Is the reflection in the line y is equal to x. It's a reflection in the line y. That's what I want. Okay, that's the answer that you're looking for. Alright, let's just take this off. In 8.5, we are told, write down the range of f and g. So what is range, people? The range is all possible y values. Okay. The range is all possible y values. Okay. So, if you're looking at the f graph, does this graph exist at negative infinity on your y? Does the graph exist at negative infinity? No. Why not? Oh, sorry. Where does graph start existing at? At 0 onwards. Not so. So the range of f is y is greater than 0. The range of g. Looking at g, does g of x exist at negative infinity?